Hello everyone, welcome back to Easy Chemistry by Vennela. From Monday to Saturday, I upload chemistry shorts from GATE 2026 questions. In today's Sunday video, I will give the concept based full length explanation. So let's begin. The first question is, major product formed in the following reaction is. In this, first it will take place protonation of alcohol. Here methyl and methyl. Here protonation will take place. Then removal of water, 1,2-methyl shift take place. Methyl, methyl. Carbocation formation. Then here hydrogen forms here double bond. Then finally you will get answer like this. This double bond, methyl, methyl. Even beta elimination take place. Isopropyl type substituted alkene attached to the ring. So this is the correct option. Why these all are wrong? Here exocyclic methylene, it is less substituted. Next, here double bond is present inside the smaller ring, so it is less favorable. Next, double bond near ring junction, sterically restricted. So this is the correct one. The next question is, the correct match for the options labeled compound X, column M with the corresponding chemical shift values. Here HA is ortho to OH and meta to NO2. HB is meta to OH, para to NO2. HC is para to OH, meta to NO2. HD is meta to OH, ortho to NO2. NO2 is electron withdrawing group de-shielding large chemical shift values. OH is electron donating, shielding and smaller chemical shift values. Next, first you have to identify the most downfield proton. In this, HD is ortho to NO2. It is strongly de-shielded, so it appears most downfield, almost near to 8 ppm. So this is the correct match. Next, compare to coupling pattern analysis. Ortho coupling is 8 hedge. Meta coupling is 1 to 2 hedge. In this, HA is ortho, that is 8. Meta is 1 to 2. So this is the correct match. In this, doublet of doublet, that is 8.4 and 1.4. Here HA is doublet of doublet, HB is doublet of doublet of doublet, HC is doublet of doublet of doublet, HD is doublet of doublet. Next, HB is ortho to 8.4. Next, in HB, HC is ortho to 7.3. HD is meta to 1.4. So it is doublet of doublet of doublet. Because HB is para to NO2. It is HB is para to NO2. It is de-shielding, appear more downfield. So this is the correct match. Next, then remaining is Hc, that is first one. Here NO2 orthoproton most downfield. Next, doublet of doublet, proton with 2 ortho plus 1 meta neighboring group. Next, doublet of doublet is 1 ortho plus 1 meta neighboring group. So that is why this is the correct answer. This is the explanation for this. The next question is, correct statement about the intermediate formed in the following reaction is. Here nitrogen, pH on nitrogen. These two groups are in carbon ring. Aziridine structure. Heat aziridine undergoes electrocyclic ring open to give azomethine ylide. To give azomethine ylide. That is 1,3 dipole. It is the intermediate. It forms azomethine. So this is the reaction. In this it can form bond. This bond migrate here. It reaction with alkyl diester. Alkyl diester. This will here and it will attack here. So it can form 5-membered pyrrole derivative. It is the pyrrole derivative. Next, it is a type of electrocyclic reaction. The ring opening corresponding to 4 pi electron. In this electron involve CN bond and CC bond. Nitrogen lone pair participation will 4 pi system. It is Woodward-Hoffmann rule. Woodward-Hoffmann rule. Here number of pi electron and reaction. Here 4n, that means con. 4n plus 2 means this. You can remember this. Next, in this is 4 pi electrons. That means it is 4n. That means it is con rotation will take place. Stereochemistry of intermediate. Con opening, both sides rotate in same direction. Here aziridine is one CO2 methyl group is wedge and other one is dash. Ring opening, here CN bonds, that becomes CN double bond. Here carboanion, that is CH N carbocation. This is the reaction. Negative charge on carbon will adjacent to the this one. Next, nitrogen carries positive charge. Here nitrogen carry positive charge. In this, option C is not the con rotatory product. So this is not correct. These two are already given. This is this. So it is 4 pi 4n. That is why this is the correct one. Here nitrogen carries positive charge and carbon carries negative charge. The next question is, major product formed in the following reaction sequence is. It involves Heck reaction and Diels-Alder reaction. It is cycloaddition reaction. So this is the reaction. In this, triplet is excellent leaving group. It reaction with palladium. This is all. It forms like this. It reaction with this one, CO2 Me. It is the cycloaddition reaction. This is partial negative. It is partial positive. It is the cycloaddition Diels-Alder reaction. So final product is like this. So in this, correct option is option A. The next question is, consider the figure given below where M is metal and L is monodendrite ligand. Sigma bonding ligand group orbital LGO having same symmetry with dz square orbital of M in the octahedral coordination geometry is. It is the octahedral structure. L is monodendrite ligand already given. Next, sigma is sigma bonding ligand LGO having same symmetry with dz square orbital. M is octahedral coordination geometry. This question, ligand group orbital LGO octahedral complex and which have sigma combination ligand orbital have the same symmetry with dz square orbital. First you have to identify the symmetry. dz square belongs to EZ representation. The sigma bonding ligand combination that interact with orbital are A1G, T1U and EG. Here set of pair is dz square, dxy square. Next, shape of dz square is large lobes along plus z and minus z. Opposite face is equatorial plane. Equatorial plane. Larger weight of z-axis ligand is sigma 1 and 2. This is the z-axis. These two are larger weight z-axis ligand sigma 1 and sigma 2. Next, opposite sign for equatorial ligands sigma 3 and sigma 6. LGO required plus 2 sigma z minus sigma x plus minus sigma x plus sigma y plus sigma minus y. Or you can also write like this: 2 sigma 1 plus 2 sigma 2 minus sigma 3 minus sigma 4 minus sigma 5 minus sigma 6. Axial ligand opposite and stronger. Equatorial is negative. So corresponding EG is dz square symmetry. So you can compare these options. Here 1 by root 12. 2 sigma 1 plus 2 sigma 2 minus sigma 3, sigma 4, sigma 5 and sigma 6. This is the correct representation. Why B is incorrect? Here minus plus z and minus z not in dz square. Next, option C is all axial contribution equal to equatorial. Not in dz square. Next, all are same sign. So this is also Wrong option. For D Z square, LGO is octahedral complex. Z axis ligand coefficient is 2. Next, equatorial ligand coefficient is -1. So 2 comma 2, -1, -1, -1 and finally -1. So this is the correct answer. The next question is the correct electronic configuration of central metal ion in ferrocene with Z axis passing through the center of two cyclopentyl ring and metal ion is. Here ferrocene is iron atom. Iron atom is sandwiched between two cyclopentyl rings, eta 5, C5, H5 rings. Z axis passing through center of cyclopentyl rings. This is the Z axis. dx square y square is xy plane between rings. dz square along Z axis. dxz, dyz are pi orbital ring opening along Z. In this, oxidation state and electron count is, each cyclopentyl ring ligand is 6 electron. Next, Fe plus 2 is D6. So total electron satisfies the 18 electron rule. The question asks only D orbital. Fe plus 2 D6. Ligand field splitting in ferrocene. It is high, lowest to highest. Lowest to highest. That is here dxy, dx square y square, dz square less than dxz, dyz. These two are between ligand. Least repulsion, least energy. This is cyclopentyl. These two are strong overlap. Cyclopentyl pi orbital. Next, it is highest energy. This is highest filling of d electron fill from lowest to highest. It is d square xy, d square x square y square, dz square, dxz 0, dyz 0. This is the order. So you can write like this. So that is why this is the correct answer. If you found this video helpful, please like, share, comment and subscribe to Easy Chemistry by Vennela for more GATE questions. Thanks for watching.